I wanted to start with this slide from 2007, which is a summary of what got us involved in the issue, because we've been conducting research on blue whales going back to 1986, focused on local ID to track abundance changes and movements changes like Jay presented. But in 2007, we were working in the Santa Barbara Channel in August and September when the ship strike started to occur. And so right away we started to explore ways that some of our data and insights both were useful to understand what had occurred that year, but then targeting and focusing some of that work in future years. Monica presented something yesterday on trends over time, and I wanted to pull in a different region why we think this is an important issue in many other areas, not just the Southern California bight. And this is taking our Cascadia research response to large whale strandings in the Pacific Northwest. This is taking 10-year periods and looking what proportion of the whale mortalities that have been documented in the Pacific Northwest can be attributed to ship strikes. The N is at the bottom, so 10-year periods. And you can see that in the last 10 years, we've seen a fairly dramatic increase with over a quarter of the whale strandings having a link to ship strikes. Now, I don't think this pattern should look this way. 1991 to 2000 encompasses the unusual mortality event for gray whales. So this year was dominated by gray whales, and gray whales have a lower proportion of ship strikes in the animals that are found on the beach. So it kind of drove this down. I think this is probably, this bar should be up here if I pulled gray whales. So our goals for this research related to ship strikes are, first of all, looking at that more fine-scale distribution of animals in areas like the Santa Barbara Channel. A number of the animals that were ship strike have washed up either or shown up floating in the Santa Barbara Channel or in areas like San Miguel Island bordering it. And we wanted to look at how our small boat surveys and photo ID could serve to provide insight into the more fine-scale areas that they're using. We're also starting to use satellite tag locations with some work that the Channel Islands Marine Sanctuary is supporting, and using that as a way to look at what habitats and areas do animals use. Some examples of that. We're interested in what the behavior of the animals in the shipping lanes is. What are they actually doing there? What has attracted them there? And how is their behavioral pattern through day-night influence their vulnerability to ship strikes? What insights does that provide to the ship strike issue? And thirdly, how do they react to the approach of vessels? And how is that interaction occurring? Specifically, how can that help us in evaluating what mitigation strategies might be effective? So starting with this distribution question, we tend to have a lot of blue whale sightings because our goal is to go out and find blue whales. So in these tracks here, this is the Santa Barbara Channel. You see the shipping lanes, 2007, 2008, 2009. The little faint white lines you see there are our boat survey tracks. You can actually see we had a lot less effort in 2007. We were not as focused on the Santa Barbara Channel and the ship strike issue. We didn't try to survey the shipping lanes specifically. Yet, even though we weren't focused on that, and in our limited effort, we did see several areas as we were doing that work and these ship strikes initially occurred, where we were seeing overlap of dense feeding concentrations of blue whales with the shipping lanes. And for the first time in my work, as we worked with blue whales, I was dodging ships. And it was striking me even before the first whale had washed up. This is a little different than normal. And part of it was this typical concentration of blue whales was more spilling up north into the shipping lanes. I guess I can use the pointer and not jump. And then when we looked at our data of how many animals we identified about 200 different individuals in these few surveys in this period that these ship strikes were occurring. And it represented a higher rate and higher number of individuals identified than in all our previous years working in that area, with actually less than average effort. So what was apparent to us is we had both a higher number of blue whales using the Santa Barbara Channel in 2007 and a greater overlap with the shipping lanes than we typically see. And to us, that then fit into this pattern of what explained why we had this unusual number, a high number, an estimated 4 blue whales struck by ships in the Southern California bight. Looks like at least 3 of them were in the Santa Barbara Channel area they were discovered, but how far they drifted, where the ship strikes occurred is not typically known. And again, a point I just want to keep emphasizing, and I think it'll be good in our panel, this just represents that small portion of mortality that is documented. We know strandings represent only a tiny portion of mortality, and would suspect that that would mean if you discover a certain number of mortalities, there are quite a few more, and so documented ship strikes represent just a minimum number. Now in 2008, 2009, we started to increase our coverage and starting to actually do some dedicated, you can actually see our faint lines in the shipping lanes where we're actually trying to sample. So you actually see more animals in the shipping lanes in 08 and 09, but that's now the result of our dedicated effort to target the shipping lanes. But it still met our goal of trying to identify where are the places in the shipping lanes where we see these conflicts and overlap between whale distribution and ships. And again, looking at it on this much more localized fine scale than you were just seeing in the last presentation. And we did find in each year there were areas, some of them in common with other years. For example, this area on the north side of Santa Cruz Island where the shelf edge comes along, and blue whales typically tend to concentrate along this shelf edge, and it intersects the shipping lanes here on the north side of Santa Cruz Island. And both in 2007, 2008, and even though shifting slightly in location, 2009, that's to us this consistent pattern year after year where it is an area we see overlap between whales and shipping lanes. And just to look at a blow up of 09, and again, our effort, this includes the shear water and work done with the Channel Islands Marine Sanctuary. You see this very large concentration of humpback blue and fin whales. In this figure here, you have blue whales that are squares, you have humpbacks that are circles, and you have fin whales that are triangles. And again, you tend to see concentration along some of these shelf edge areas. Here's this overlap area where the shelf edge, as it comes along, it's a gradual drop off and intersects the shipping lane here. We also found this area here, an area of Wainini Canyon, where we had a concentration of feeding blue whales. Now, instead of being, these were in the outbound shipping lanes that overlapped, was an intersection between whale concentration and shipping lanes. And we did have this area here that was a little bit more of an ephemeral area, though you don't see it in this figure. We actually sampled this area several times, and the whales were shifting around in that area. It wasn't associated with a specific bathymetric feature, a topographic feature, and it seemed to move around. We had trouble tagging whales in that area and approaching them. They were fairly variable. Jessica mentioned the other type of data we get is from satellite tags that can give us insight into where animals use. So now you're looking at just the locations from 9 satellite tags deployed on fin whale and blue whales. And this is looking at the kind of Long Beach, LA area where these animals in late 2009 spent about 3 weeks intensely feeding. And so it gave us a good picture. Red squares are fin whales, circles are blue whales. So you get lots of data points, but keep in mind that's only 9 individuals. But it's another way to look at habitat use by putting satellite tags on these animals, and especially areas where there might be low densities. This can be an effective way to get a satellite tag on an individual to get quite a bit of information on the habitat that animal is using. Now we've also worked up in the Gulf of the Farallones and off San Francisco Bay. San Francisco's right here. You have shipping lanes coming out past the Farallon Islands, which are here. And there the carb rule has affected shipping traffic as well. These west shipping lanes here have become the heavily used shipping lanes there, with these coming up closer to shore, now less used. And in October 2010, partly due to the carb rule, we've had a harder time finding blue whales in the Santa Barbara Channel, so we shifted some of our effort up to this area where we were hearing that there were whales in the shipping lanes. And indeed, this is the results from the blue tracks are our vessel routes. Just 3 days of surveys. We had lots of sightings of humpback and blue whales shown by these squares, many of them in the shipping lanes. And in this case here, here's the shelf edge comes up this way, and we found quite a concentration of animals right along that shelf edge again. And this was an intriguing point for us, because what we realized is by these shipping lanes ending where they did, just short of the shelf edge, as we tracked the ships that came up, they tended to come up along the shelf edge and then turn in, or come down along the shelf edge and turn in. And that would put them basically traveling right along this area of highest whale concentration. And a very simple fix of extending these shipping lanes out so that animals would cross the shelf edge at a right angle instead of traveling right along it as they turned in would be a very easy way to shift them away, minimizing the amount of time. You still can't avoid ships crossing the shelf edge, but you can keep them from just going right along it, which this seems to invite. And this is just from one day, and in that site there, we actually witnessed 3 reasonably close encounters of whales and ships. This one here, if you see in the background, there are actually whale blows against the side of this ship here, so this actually isn't the close whale. There were a couple of ships that looked to us to be in tens of meters to the side of the ship. And this one here I showed because this is the footprint right here of a blue whale. That the ship went by and the whale surfaced directly in the wake, and so we were surprised in just one day to witness these occurrences. Our tagging data is aimed at looking again at behavior in the shipping lanes and what the animals are doing and how they react to ships. We've been using this to look at prey associations for a while, going all the way back to 1999. But now we're concentrating on what issues does it provide, what insights does it provide into the shipping lane issue. And one thing we do is looking at the dive record of an animal from daytime to nighttime to then daytime. We see a dramatic shift in how deep. This is depth along this axis. We can plot what % of time in day and night these animals are spending in the surface water. And it basically shows that down to the depth that a ship might strike a whale, a blue whale at night spends almost twice as much time in that shallow area than it does in the day, so a higher vulnerability to ship strikes. And this is just a plot from one animal, but we have about a dozen of these data points through the night, and they're all fairly consistent along those lines. The exception you see is how deep whales are diving in the day. In 2010, we did see a lot of surface feeding, so that would have been a year that daytime vulnerability was also high. We've been trying to look at, and this is hard, this data has proven hard to get, especially the CARB rule of moving ships out of the Santa Barbara Channel has made this harder to get, but we've been putting tags on these whales right when they're in the shipping lanes and looking at what happens when a ship comes through the area. It can be hard to find a whale, hard to get a tag on a whale and to have it be in the shipping lane and then a ship come through. You're trying to get a bunch of stars to align. But we pulled this off about a half dozen times, 4 of them with approaches that were fairly close, within a few hundred meters of the whale. And so this is, for example, all the movements of one particular whale. It shows all where it was moving. And this yellow is the track of the ship that came through. And this white arrow and point here shows where the whale was and where it headed at the time of closest approach of the ship. And in this case, this was about 600 meters away. But we have a number of these. This was an even closer approach here where the whale was under 200 meters away as the ship passed. And in 3 or 4 of these cases, the direction the whale was traveling at the time the ship passed through was closing the gap. So 3 or 4 isn't enough of a sample size to say I don't think that's worth concluding they're attracted to ships, but it suggests they're not avoiding the ships. They're not moving away. There's not a pattern. So we shouldn't assume, even if animals detect these ships, they're going to avoid them. We've also been looking at how their behavior changes. So this is a track and dive behavior of a whale. The shaded areas show 2 different time periods where 2 different vessels made close approaches. And then these are blow-ups of these shaded areas. And what happened in this case was the star shows where the ship close approach was. And the surface series immediately after the close approach for both of these were the longest 2 surface series in the entire dive record we had. So there was a hint that right after the ship passed, there was a delayed reaction by the whale where it spent more time at the surface. Whether, if that was directly over the whale rather than a miss, that might have occurred sooner. That's an open question. We don't know. We're sort of projecting what might happen in a more ship strike situation. But again, it doesn't suggest the whale's diving behavior is necessarily to avoid the ship, and there's the possibility it could react in a way that would make it more vulnerable to the ship. Whales are not, evolved to react to ships. This is a recent strike. They're reacting to in ways that might have been adapted to a historical threat like a killer whale attack. And so if they perceive a threat, we shouldn't expect them to react in ways that reduces that risk. So basic conclusions, 2007 we did see some unusual patterns that we think seem to explain the high mortality event of that year. Whale use was lower in 08 and 09. Most of these kind of intersections of whale density and ships in the Santa Barbara Channel seem to relate to shelf edge contour, some features that you could predict and design shipping lanes to avoid or minimize time in. And our tagging data is showing not necessarily any avoidance of ships in close approaches. We're seeing some evidence of increased surface time and some indication that risk is highest at night. And those conclusions kind of bear on value of things like observers as mitigation strategies, or observers wouldn't be very effective at night if that's when the risk is greatest. And my final slide is just future needs directions. Jessica made reference to this, better analysis of some of the non-systematic data. I can sort of show how they overlay with the shipping lanes, but we haven't tried to conduct the more sophisticated models like what Jessica talked about. And since we have all of our effort, you could develop effort-corrected sighting rates and model that. And I think there's some use in that because we, I think the Southwest cruises have, I don't know how many sightings in the Santa Barbara Channel. It's a very small number, and we have hundreds to thousands of them, but you need to adjust for effort because it's non-systematic. Clearly trying to understand whale habitats and behavior in this shipping lane from either targeted surveys and satellite tags would be beneficial to fill some of those gaps. And we're still think there's a need to expand the sample size on how whales react to ships. The few that we have been hard to get and harder to get with the movement of ships away from the Santa Barbara Channel, but we are trying to get it in other areas, and we'll keep focusing on that to look at, are they avoiding ships? And that gets at, if you put some sort of alarm system on a ship that let a whale know there was a threat there, is that a good thing or a bad thing? It may not be a helpful thing. Okay.
Yeah, it might be worth, you said close approach and you talked about 190 to 600 meters. It's probably worth remembering that the ships we're talking about are verging on 300 meters long. So that's less than a ship length away from the beach.
Yes, thanks for pointing that out because I think it's a good point. And when I had envisioned this issue of close approaches, I was sort of thinking, well, we'll find a whale in the shipping lane and then a ship coming through, but the shipping lanes are a mile wide, and that's not as close an approach. We were really trying to document things on a pretty close scale because that's the only place I think we might see a reaction that's meaningful in terms of the dynamic that might put a ship to be struck. But these are very close distances, and it has added an interesting element trying to be there and capture that and kind of move out of the way of that, but capture whales that are right in that track.
Does deeper diving correlate with dive time? I'm just thinking if you said it did more of the deeper dives during the day in some years, assuming someone on the ship was trying to avoid whales, does that mean whales are coming up less frequently and less chance of seeing them?
Yeah, I mean these deeper dives are generally a little bit longer that you see. They're not. There's an interesting paper just coming out, Jeremy Goldbogen, who's been analyzing some of the tag data, talking about some of the energetics of, there's sort of a fixed number of lunges they do, and they're not actually diving as long as you'd think blue whales would be capable of because these lunges are fairly energetically costly. But they are longer dives. When a blue whale surface feeding, it's doing rather short intervals, and at night all of the dive intervals are short, and the daytime is these much more clumped series of surfaces, sometimes for 2 to 3 minutes at the surface, and then a dive of up to 15 minutes in between. And it also gets at why an observer sighting a whale at the surface ahead of the ship could be a very difficult proposition when they're in that deep dive mode, because they're going to sight a whale that's at that surface series, and that whale's going to either be far ahead of the ship, and that's probably going to mean a whale that's going to be on a deep dive by the time the ship gets there, and that might not be the most critical whale to avoid. And the whale that surfaces close that you're going to hit within a minute or two while it's still at the surface, that's the whale the ship wouldn't have time to adjust course. So even kind of seeing a whale, you can sort of see with that dive pattern you're describing, can make it more challenging to really how would a ship avoid it. Yes.
John, I was kind of surprised by all this, that there was never even a picture of a United States Navy ship. Do we not look at those? Is there no record of Navy ships hitting whales?
No, actually, I think Monica in some of her past talks has made reference to the fact, if anything, the Navy is very well represented in the
Yes, yeah, it's part of their reporting requirement, and the Navy, the military is very, very good at reporting when they have ship strikes. So unfortunately, when you look at the database, they seem it's biased for that reason, that they're very good at reporting. So it's not that they're necessarily hitting more whales, they're actually better at reporting.
I mean,
Was there no mention of those?
Some of the few instances, even when big ships come in with a whale wrapped around its bow, typically the ship will be unaware and not have reported it, but yet there are almost all of the reports of real time, I know I hit a whale. I don't know what proportion, but I know it's a high proportion are the Navy ships, because they are on watch, they are catching it, and they are reporting it. So it is occurring. It's not tending to occur in these shipping lanes. I know that the ship strike locations I've heard about have generally been further south in the area where they do exercises and coming and going from San Diego. So it's sort of like a different region than this, and it didn't seem like it was involved in that kind of ship strike, increase in 07. I don't know if you want me to take more, or you want to defer it to the...
Yeah, let's defer it to the panel.